Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Justin Davis. Justin is a senior product manager at Planet. And if you haven't heard of Planet before, they manufacture and manage the world's largest constellation of Earth observation satellites, imaging just about everywhere on Earth just about every day. So they have this great tagline. It's making change visible, accessible, and actionable. And the hope of this podcast episode is to help you understand how they do that. So along the way, you'll hear about their two constellations that they operate and how they work together. You will learn the difference between ghost ships and dark ships and find out that there are surprisingly few ground control points in the middle of the ocean and why that matters. And we'll also talk about what all this means for GIS and permit enforcement. So we cover a lot of ground in this episode. And after listening to this, if you have more questions, there'll be a lot of resources in the show notes today. One of them will be a link to planet.com/GIS, where you can learn more about integrating Planet data and insights into your GIS system. And there'll also be a bunch of podcast recommendations to related topics that I think that you'll find interesting. Before we get started today, it's worth noting that Planet helped cover the costs of producing this episode for you today. They will also be sponsoring several upcoming episodes. Without companies like Planet sponsoring this podcast, there is no way I could produce it for you. So I am really, really grateful for their support. Hi, Justin. Welcome to the podcast. It's an absolute pleasure to have you here. You're the senior product, or maybe you are the senior product manager at Planet. Welcome to the podcast, man. This is exciting.
Thank you so much. And yeah, we can stick with the indefinite articles. I'm a senior product manager at Planet, but yeah.
Maybe you should work on that. Like the senior product manager would be great too.
I mean, someday I'll reach the status.
I'm rooting for you. So first of all, what is Planet? And then secondly, what does it mean to be a senior product manager there? What do you do?
So Planet is a fascinating organization where we manufacture and manage the world's largest constellation of Earth imagery satellites. So we create these satellites, and once they're up there imaging the Earth, we handle all of the processing of that data, all of the publishing of that imagery, and the delivery of those images and insights to a broad range of different organizations and users. Yeah.
Wow, you do a lot of stuff. So this is Planet, the organization.
Indeed.
What about your role there?
So I've been with the company now about 6.5 years. And for the majority of that time, probably about 5 years worth, I've been focused on computer vision, machine learning, artificial intelligence services, basically making it easier for our users to get value out of this massive amount of data that we're generating. Because we are imaging just about everywhere on Earth, just about every day.
Wow. It's like I'm used to hearing people talk about this kind of stuff, but it still blows me away when I think about the practicality of that, how it's even done. So if you don't mind, I'd like to talk about that just for a second.
Sure.
How many satellites do you need to do this? How many constellations?
So we actually have 2 constellations currently in operation. One is our PlanetScope operation, or the satellites, we call them doves. Now, for those, we have around 200 satellites in orbit, capturing just about everywhere, just about every day. As the Earth rotates, these kind of act as like a string of pearls going like across the poles. And so as they kind of come down the Earth and the Earth rotates underneath, they're just constantly imaging. So it's basically like a line scanner for the Earth. And so with this constellation, we get about 3 to 5 meter resolution. So each pixel is 3 to 5 meter by 3 to 5 meter. And in a myriad of different bands, we have 8 bands for this constellation. So that's red, green, blue. We actually have 2 green bands, a yellow band, a coastal blue band, a near infrared, and a red edge. I think I said those out of order, but those are the 8.
Wow. Okay. So we have other constellations, other satellites somewhere in the background?
Indeed.
Okay.
Yeah. So in addition to those, which is kind of like the monitoring mission, which basically lets us monitor the Earth just about every day, we also have high resolution satellites. So these are capturing at 50 centimeter resolution. And we have about 20 of them up. And while the PlanetScope constellation is always imaging, looking straight down, and so wherever they are in orbit, they are capturing imagery below them. Our high resolution constellation of SkySats, they need to be tasked, which basically means we just need to tell them where they should be imaging. So rather than imaging all the time straight down with those, we actually can kind of point them to wherever they need to be capturing.
So you mentioned monitoring before when you talked about the doves.
Yeah.
Tell me about the relationship between the doves and these higher resolution satellites.
What a fantastic question. So, really, this is why having these two constellations are so powerful when you have them together, because we have this monitoring mission, which can really be looking for changes across the planet. And I mean, a planet, we say we are imaging the Earth every day to make change visible, accessible, and actionable. And so that's where the monitoring PlanetScope doves come in. And with those, we can find changes and then point this high resolution assets or satellites at the places where change is taking place. So with one constellation, we find where things are happening. And then with the high resolution, we can really kind of zoom in, quote unquote, and see what's happening.
I want to talk about change and perhaps even meaningful change in just a second here. But how long have you been doing this? Like, how long have you had these constellations up? How long has this process been in place? What does the archive of data look like? I guess is what I'm asking.
Yeah. Well, so Planet was founded, I think, 10 years ago. But we also have in the archive, we also have the publicly available data of Landsat and Sentinel-2, which we'll probably talk more about. But that's available. So as far as the archive, it goes pretty far back. We reached mission 1, which was that mission to image everywhere, every day, in late 2017. So since late 2017, we've been capturing, we have near daily archive. And then we also have archive from a separate constellation called Rapid Eye, which goes back to 2009 even.
Wow. Okay. So got a lot of
Yeah.
images. We've got a lot of pixels of the Earth, and this is. I'm glad you sort of walked us through that because this is going to help us establish
Mm.
a baseline. And when I say baseline, I mean when we're talking about change. We need a baseline to say, okay, this is change. That's one thing, and this is meaningful change. Is this the only way of deciding what's meaningful, non-meaningful? Is this huge archive of data that you've got just by looking at the baseline, or do you need to do something else as well to figure out what's meaningful when we think about change?
Well, first off, I love that you're making the distinction between change and meaningful change, because if we just do straight up pixel diffing between two images, you're going to find a whole bunch of stuff that no one cares about. When we talk more about meaningful change, I think what you're kind of starting to refer to is more like anomalous behavior, sort of like anomaly detection. And so with a deep archive of imagery, you can set a baseline of what to expect. And then if what you observe differs from your expectation, that's kind of anomalous. And that seems like something that is worth taking an extra look at. Even when there are anomalies, though, I think depending on your use case, depending on who you are and what you're trying to do, that might not be meaningful at all. That might just be something that you just ignore. So when we talk about meaningful change, it becomes a pretty subjective conversation quickly. So like I do like anomalous. If we're talking about something that's unexpected, something that you haven't seen there before, or maybe you haven't seen there before recently, that I think is a good indication of something meaningful to look at.
Yeah. But I think what we're establishing here is a difference from the baseline is not necessarily valuable, let's say, to a particular end user.
Yeah, I think everyone's use case can be a bit different. I mean, I think one thing that's really interesting is the number of different use cases and markets and industries that can get value from this type of information. So, what might be interesting to some might not be as interesting to others.
I forgot to ask you about the constellations and the imaging, and you said everywhere on Earth, everywhere, every day. Now, I know some of these. This is also over the water. I'm assuming, so not just land, but it is the entire globe that we're talking about.
So yeah, it's a really good distinction. We are capturing the Earth's landmass just about every day. But in addition, we are capturing a significant amount of open water imagery. I believe something like 10 million or maybe even more square kilometers of open water imagery. And this is just where we see significant demand from a various number of customers or users. But in addition, I should also mention, we are capturing about 15 kilometers offshore. So we do get global coastline. But as you go further out, we are capturing about 10 million or a little bit more than that square kilometers of open water imagery.
Is this something that's limited by the constellations that you've chosen, the orbits, or is this something that you just turn off the switch because you're capturing value, data? Sorry, that's maybe of not of any value to anyone.
So what's actually really interesting, it's the way that our satellites image that makes it possible for us to be able to extend out over open water. So with satellite imagery, you need to be able to tell where the image was taken. And so we use sort of ground control points on the Earth as kind of reference points to be able to say, okay, this image that was taken is actually I don't know, Providence, Rhode Island. And because there's little markers basically that we are able to map to. And so we know that that image is in that location. Over open water, there's really nothing that you can say, oh, this piece of blue is that one that's in the middle of the Atlantic Ocean. There's nothing to really map it to. So the way that our line scanners with PlanetScope, the way that they image, we can extend and extrapolate where the image is based on where it was at shore. So the further you get out, the less accurate it's going to be, but you still have a good sense of where you're looking.
That is really interesting. Honestly, this sounds incredibly naive when I think about it, but honestly, I thought knowing the details of the orbit, for example, and that the 6 degrees of freedom of that satellite, where is it pointing, was going to be enough to project down at the Earth and say, okay, this footprint of the image is here.
Well, that's where it starts. So with that information, you can then be looking for these key markers that are on the ground.
That is, again, I think that fascinating.
Yeah.
Let's stay with shipping and the water for a minute.
Hmm.
And I'm just imagining a couple of use cases, but they're going to require an explanation. And these use cases that I'm thinking of are dark ships and ghost ships. Maybe you could start by
Yes,
defining what those are, and then we can the use cases will sort of come off that.
absolutely. So yeah, when we're talking about open water, like I mentioned, is just a lot of blue, probably a lot of clouds, some waves. What people are really looking at are ships. They want to know where the shipping activity is. Is illegal fishing happening? Is there embargoed countries, engaging in trade that they shouldn't be? So with shipping and generally ships in general, there is this thing called AIS. And there are other signals as well, but AIS is probably the most well known and the most prevalent. And ships basically have to send off this little beacon, this little signal that indicates who they are, where they come from, what they're doing, just general basic information. And this is used for a myriad of different reasons, one of which just making sure that ships aren't going to collide, and it basically lets people know where they are, what they're doing. A lot of times, ships will turn the signal off, and they can do that. They turn the signal off, and then they do something, who knows what, and then they turn them back on. Usually, when the signal is off, it can indicate they're doing something that they probably shouldn't be doing. And so, really, without the visual evidence, without a satellite image of the ship, you can't see them. And so these are called like dark ships. When a ship goes dark, they're not emitting their AIS signal. The reverse is also true. People will spoof these signals to places that there are no ships there. And so that is kind of like a ghost ship, where basically they're emitting a signal that says, I'm actually over here, but there's nothing there. And so satellite imagery can help identify these dark ships when they've gone dark, and they can identify that there's no ship in a place when there should be. Generally, this will involve some sort of automated ship detection service, product, model, thing. And that's really where computer vision and machine learning and AI and all that good stuff can really come into play for this type of thing, because these models are actually very good at being able to detect ships over large bodies of water. So once you've made that detection, you can just kind of fuse it with where you're seeing the signals, and where they don't match up, that's a dark ship or that's a ghost ship.
And are we back to the idea of using the doves to monitor, looking at the baseline, saying this is different, for example, and then tasking a satellite to go and have a closer look?
Yeah.
Okay, so I'm sure you're doing other interesting stuff, on the waters or over the oceans. But let's move on to land now. What does this mean for people on land? What kinds of things are you looking for? How are these two constellations working together?
Well, so all sorts of things in a nut. Like, where do we want to start? I mean, generally, I think all of our customers are trying to keep up with how the places they care about are changing. So, for a property manager or a civil government or anyone that's trying to keep up to date with a large area, without satellite imagery, you're generally going to have to be driving out to these places and trying to see how things are developing, right?
So it sounds like we're making this distinction between monitoring and mapping. And when you say that your customers, the people that you're seeking to serve, are interested in this change, it kind of assumes that they already know that they've mapped everything. They know the way things are today and what they're really interested in. Do they change over time? Maybe you could tease apart this idea of monitoring and mapping for us.
Yeah. Well, I think you kind of just nailed it. Basically, I feel like mapping is what is there right now. And so what does this look like at this point in time? whereas monitoring is like making sure that that map or what's been mapped remains up to date. So this is where all the roads and buildings are today, but tomorrow or 2 weeks or in a month, it could look a little different. And so making sure that those things are getting updated is kind of, I think, the difference between monitoring and mapping. Or maybe like ongoing mapping is monitoring in a way, perhaps, question mark. But that's kind of like how I would think about it. Monitoring is kind of a through time. I'm continuing to stay up to date with how all of the places that I'm responsible for, if I'm a civil government or whatever it might be, are still accurate.
Okay, so we're assuming that, like, when you talk about people, most people being interested in this idea of change, has meaningful change happened? Meaningful change to them happened, and they want to know about that and figure that out. So they've got a pretty good understanding or a great understanding of where their things are today, where their assets are, what their landscape looks like, and now we're more interested in, is it changing? How did it change? Like, so I'm thinking about infrastructure. This must be a, I don't want to say easy, but like an obvious place to start for a company with your kind of satellites and your kind of access to data.
Yeah.
So infrastructure, roads, buildings, that kind of thing. Are we looking for change over time with that, or do you focus on something else?
That is exactly, that was really the first foray into computer vision, machine learning, AI stuff. That was really what we were looking at. And there's many reasons for that. One, like you mentioned, it's kind of the thing that's staring you in the face. Infrastructure change is something that we should be able to do a good job with. And the real reason for that, when you look at the imagery sources that are out there right now, or before Planet, there was really Landsat 8 and Sentinel-2. And they are incredible sensors that are so valuable. And they've provided this long-term archive. And these are public sensors. All this is freely available. Sentinel's managed by the European Space Agency. Landsat's managed by NASA. These are fantastic assets. But their spatial resolution is a little bit less or higher. You always get like, it feels a little backwards, but their spatial resolutions are 30 meter and 10 meter, whereas PlanetScope or the Doves are at 3 to 5 meter. And so we were looking at what can we see a bit better? What can we make out in PlanetScope that maybe is a bit more difficult in the 10 meter Sentinel? And roads and buildings were really the things that pop. And so that's what we started with, seeing could we use supervised classification methods, semantic segmentation, to be able to classify the pixels in an image into roads or buildings. So that was one reason. Another reason is the broad applicability of that. So whether you're a civil government, a federal government, a NGO, there's all sorts of different use cases for why roads and buildings would be important. Generally, it can indicate where populations are. It indicates new human development. And there's all sorts of reasons why you would want to know why that's taking place.
You talked about classification, so
Yep.
pixels. Is this pixel a road? Is it a building? Are we in fact talking about making like image masks, or are we talking about making discrete objects, so building footprints, for example, out of these classified pixels?
Yep. So it's kind of like a funnel, I would think of it. So with the PlanetScope monitoring, we are trying to direct people's attention to where the change is taking place. In that resolution, it's going to be really difficult. Yeah, it's going to be really difficult to create a building footprint. But in a high resolution SkySat, for example, becomes much more tenable. Because then basically when there are buildings tightly packed next to each other, it's going to be really tough to delineate which building is which. But if you're looking at building development through time, you can start to see, oh, there is new building development taking place over here. Hey, SkySat, take a look over here so that we can get like the actual detail of what that building is. So we're using semantic segmentation to direct people's attention to where at a pixel level, we're seeing signal that there's new development happening. And the same thing goes for like routable road networks. So really on the first level segmentation or semantic segmentation results, those are kind of per pixel raster type masks, if you will. But then the change detections are going to be more vector-based polygons that are basically just saying, this is a place you should be looking at. And generally, users will already have pipelines or processes for, oh, something's new here, plug that into what I usually do anyway.
Yeah, yeah. But the point is you're telling them that something is new here.
Yeah.
What about routable road networks? That sounds interesting. What are you doing there?
Well, so at this point, we're still focusing on helping people stay up to date with massive areas. So for example, we are monitoring all of Brazil. So 9 million square kilometers of some of the more difficult areas to monitor because there are just tons of clouds. in over most of it. And there is so much land to protect. And so basically they want to know anytime development is taking place over protected lands, they want to know about it. So that's both buildings and roads. And also we also always see, or at least most often see, roads get developed into a forest before deforestation will take place. So early indications of development are crucial in those types of places. So really, at this point, we are still trying to make it easier for people to stay up to date with these massive areas. Because again, we're capturing just about every day, just about everywhere, just about every day. So how do we help people manage that massive amount of data and that massive amount of land?
Yeah, like to be honest, it seems like an impossible task without satellites or, without a huge amount of infrastructure. Yeah, I think that's the way I should say it. Without a massive amount of infrastructure, I have no clue how people monitor things like the rainforest in Brazil. No idea.
Yeah. So I also should mention, even in places that are much more accessible, people just might not have the resources available to be able to stay up to date. So the New Mexico State Land Office is is an office that we work pretty closely with, where they need to stay up to date with the new rights of way that are being developed or the new roads that are being developed, so that they can make sure that they're collecting the tax revenue that comes from those types of things from when people are getting more oil. So they can look at permit applications that have been made and then use our change detections to see whether change has happened before the permit got approved, or if change is happening where no permit has even been applied for. So with that, they're able to generate a massive amount of estimated tax revenue.
Yeah, well, it always blows me away, those use cases. They are so niche, but the implications are massive, right?
Yep.
The implications are, the state collects the tax that it's owed. It can go and build roads, hospitals, schools, infrastructure for the people living there. But it's just so niche.
So in that particular case, yes. But in general, permit enforcement is something that we're seeing come up constantly. And so people will apply for permits to develop something, or they won't. But if we can shine a light on where that development is happening, it makes it possible for, again, these organizations to keep up to date with these large areas that they're responsible for. So whether it's like hoop house development in particular counties where cannabis is legal now, but they need to be applying for permits to be able to grow it, this is something that we can help with. This is something that we can show this development taking place. So in addition to roads and rights of way, there's also, building structures. There's tax on new building developments, where it was interesting. Earlier, we were talking about people will generally have an established map of what's there, and then they'll use the monitoring solution to find out where new things are coming in. More often than not, we find a lot of development that the organization was not already aware of. So yeah, I just would reiterate that permit enforcement is something that's coming up quite a bit.
So I was, you can confirm or deny this story, but it was a fascinating story.
Sure.
Someone from Google told me that they use planet data to figure out where the new roads are being built. And we've just been talking about roads, but their pipeline, as they described it to me, their pipeline looked like this. It was, we can see a bunch of Android phones driving through the field. That seems weird. Then they look at it again. 2 days later, there's still Android phones driving quickly through a field, a lot of them. And then so that they task one of your satellites, go and have a look. And this is one of the ways they update their roading layers.
I believe that is true. It's interesting because it kind of makes me think about something I hear fairly often with computer vision, machine learning, AI stuff, is people are like, so why I don't need imagery now? And it's like, no, you definitely still do. This is something to make it more efficient. It's something to make it so that you're not looking at every image we publish, that you're not needing to be going back and forth for multiple days and being like, what changed here? It's more about pointing people's attention to where this stuff is happening. But you still need to be able to validate that that is a new road, that is a new building, and that image is always going to be necessary.
So you're sort of alluding to this idea of ground truthing with our eyes. So if you show me a map of change, like this building has changed, this area has changed, is it then the case that I can go through it and double click on that and find out here is the documentation by visiting your archive? Is that what we're talking about?
Yeah. I mean, well, for this type of stuff, yes. When it is something that you can see with your eyes that there wasn't a building there and now there is, there are times when it'll look like a white speck, and that's where our SkySats will come into play. And then you can really zoom in and be like, okay, that is a building. There's also, other analysis that you can do with our imagery with the non visual spectrum. So like the near infrared and maybe other things that aren't visible to our eyes. So like crop health and things like that, where you're using, just sort of standard spectral indices, that also will come into play. And with those, it'll be tougher to be able to say, well, that crop looks pretty unhealthy based on, I don't know, my eyes. It'll be much tougher.
When you talk about consuming this data, you talked about pipelines before, and that'll feed into this pipeline. It almost feels like this is something that only massive, massive organizations can do. This is, very specific people that are already like cloud native in every way possible. They can pull in this stuff and then do, add it to their own sort of magic pipeline. If I was a GIS analyst, if I was a GIS manager somewhere, can I do this too? Like, can I pull in a feed somehow into my QGIS, into my ArcGIS, into my whatever else I'm using and do this?
Yep. So this kind of goes into what I was saying earlier about like the totally varied users of this data and the myriad of ways that it can be consumed. For your specific one about GIS users pulling it into QGIS or ArcGIS, yes. We have plugins that can help you pull in the actual imagery to be able to do analysis in ways that you may already be used to. We also have for some of our what we call analytic feeds, which are like the ones that will generate some of these change detections or ship detections, things like that. We also have a OGC features integration where you can pull in the actual vector data into GIS to be able to fuse with whatever data sets you may have. So like in the permit enforcement use case, if you have a whole database of permits and they're lat longs, you can, in a fairly straightforward way, fuse those together to find where they don't match up, where the dark ships, ghost ships, all of that type of stuff. But I think what you're pointing at is something that we are really looking at. I mean, Planet probably 6 years ago was known really as a satellite company. We're manufacturing satellites. They go up there and we're like that was like the space is cool. We're a satellite company. We're now much more of a data company where people need to sort of know what to do with the type of data, whether it's raster or vector and that sort of thing. But we really want to be transitioning into more of a platform company where people don't need to necessarily know how to be an imagery analyst. What does near infrared band mean? Like all of that type of stuff. They won't need to be experts in order to do it. And you won't need to be a software developer to know how to integrate with our API in order to surface it into a UI that might be bespoke somewhere. We want to make all of that stuff a lot easier. And so we're really transitioning to that platform type of company.
So we've been talking about, buildings, roads, infrastructure, shipping, that kind of thing. What's next? Like, what can we expect to see from Planet in the future in terms of objects that I can, or, meaningful change? Are we still just talking about change in the broadest possible sense? Like, this field is different, this urban layer is different. Or are we going to be able to say, like, oh, this road is different now? This building is different.
I do want to take a second also to plug some of the other amazing products that we are developing and have launched. I mean, most recently, I think we just launched a forest carbon diligence product, which is quantifying the carbon as well as canopy height and canopy cover anywhere on Earth that trees grow. So that is just mind-boggling to me. So that's one thing. Another, we have a whole myriad of products that we call planetary variables, where we are measuring key phenomena on the ground. And that includes soil water content, crop biomass, and land surface temperature. And now those use passive microwave data combined with imagery to quantify those things. Also amazing, ridiculous, so impressive and interesting. Yeah. And then, of course, there's the myriad of agricultural use cases using all sorts of different spectral indices and other analyses with our multispectral data.
And again, are these feeds I can pull into back to my theoretical GIS manager, GIS analyst?
Sure.
Can they also get access to this stuff, or is this alone the domain of like the computer vision experts or the cloud native geospatial pipeline folks?
I mean, these are all just raster products. So if QGIS and ArcGIS are set up to be able to work with imagery, they can pull this stuff in as well. It's just not going to be an RGB image. It'll be some sort of quantification of those pixels rather than an image.
Wow.
Yeah.
Man, we have come a long way. So many years ago when I started out in GIS, just getting a base map was basically it was an impossible task. You had to build your own base maps. And now we have these services that we can just drag in and use in the platforms that we're using anyway. It's kind of mind blowing how far we've come.
And in case people aren't aware, We make base maps as well.
Yeah. Good. Good point. Good point.
Yeah.
You talked earlier about you were a hardware company. You were building satellites. You were throwing them into space from Earth, and then you were collecting data back. And now you're moving towards, now we're a data company and maybe even an analytics company as well, judging by some of the products that you're building on top of the data archive that you have. What about, is synthetic data, is generative AI, is this ever going to play a role in what you're doing? Like, is it going to, I don't want to say devalue, but is it going to affect your processes going forward? Are we going to focus on like synthetic data more, or maybe just as much as we do on collecting your actual measurements?
Sure. I mean, I think regardless of your industry at this point, generative AI and, the revolution that has been happening in quote unquote artificial intelligence is going to impact what you're doing. Let's talk about synthetic data specifically first. So I think synthetic data can be really helpful in a myriad of different ways. The one that I've seen most often is using it to quickly bootstrap training data sets for computer vision models, or more conventional supervised classification models. We've seen that be extremely successful. But ultimately, you still need the actual observations to run these models on. And you're still going to need, like we were talking about earlier, for validation purposes. Once the model says, hey, something's happening here, you're going to need a valid observation, and when I say observation, basically an image, that can back up what the model is telling you. So I think synthetic data and other techniques can really help how well a given model performs, or it can generate a whole bunch of data so that you can create a new model that is able to understand kind of the fundamental characteristics of an image rather than trying to find specific things that you've predetermined. I'm kind of getting into supervised versus unsupervised here. But I think you're still going to need the actual data to run on. Otherwise, you won't actually have evidence that what was generated isn't a hallucination. Yeah, I was just going to say, putting into like LLM concepts, if you asked a LLM, like, what are your credentials or something, it could make some stuff up. And you need to have a way of saying, I actually did not go to Juilliard in 1972, but you need some sort of ground truth.
Yeah, I was just about to say, this reminds me a little bit of our conversation earlier about, the further you get away from the coastline, the more difficult it is to ground truth the imagery and say, okay, it's actually here. So the further we get away from the truth, we have this drift that's going to occur. We need ground truth and observation to, bring us back on course.
Yes. But in terms of how the latest techniques and this revolution is going to impact how we do things, I do think it is pointing towards something in the realm of supervised versus unsupervised. And what we've seen, and generally in conventional computer vision, you need to label a lot of data to train a model that can understand what it's trying to find. And this is a tried and true technique. We understand it, we know how well it works, and we know how to do it. But what it does is it kind of locks you into a definition of what it is you're trying to do. So up front, you have to define what are the objects you're looking for and what specific objects are you looking for. Like for buildings and roads, we went as broad as possible. So we said anything that a human could stand underneath would be a building, and anything that a truck could drive reasonably safe on would be a road. There are obvious caveats to both of those things where you don't necessarily want those to be the thing, but you have to make a decision and you have to do that up front, because you then need to label all this stuff in the images and understand what it is that you're looking for. And then you spend a few months probably training models and iterating, and then you get what you're looking for. And then you might talk to a customer who says, actually, I just need dirt roads, or actually, I just need this other thing. And then you have to go, fair enough, go back, label more imagery, train another model. And so there's a lot of upfront decision-making that you have to make that you then are kind of locked into at times. Whereas with unsupervised techniques, if you can have a model that understands the key characteristics of imagery in general, and it can kind of group those together so that agricultural fields are all kind of in the same realm and forestry areas are all kind of in the same realm, then when you present it with something that you're looking for, it can say, okay, based on the fundamental characteristics of that image that you want to find, it looks a lot like these things that I have already understood and I've already clustered over here. So here's some things. Are these what you're looking for? You can be like, yeah, that's exactly it. Or no, that's not at all it. But you can make those decisions after the fact. All of the imagery has already been analyzed. Now you're doing this like in a much lighter weight space, and you can be much more flexible. But it requires having this different type of model, which can analyze the imagery differently.
It sounds like, so in large language model world, I hear people talking about these foundational models and then people build on top of them. It sounds kind of, to my untrained, mind, that's what it sounds like we're talking about. And it's been interesting in that space, if we think of ChatGPT, LLMs, now when you look at the evolution of this, like, okay, we have this baseline model of this stuff that you can use and play around with. And now people can add their own tweak to it. They can add their own data to it. And I guess I'm wondering, is this the future? Is this a possible future in terms of, satellite imagery and creating our own models, our own apps, where maybe a user like me, so not a computer scientist, could do something like this?
I think that is definitely going to be part of it. We are seeing very similar things. Like your notion of the foundational model totally applies. Foundation models, they generally mean like massive data sets have been used to train on them. Sometimes you don't need a full foundation model, but in any case, I think, yes, I do see a future where this will unlock things for more people to be able to find the things they're looking for, to be able to analyze the data in a way that it wasn't possible before. It's still somewhat early days to understand the limits and the potential of all of this. And so this is something that a lot of organizations are looking at in the industry. Like our partner Synthetic AI is definitely looking in this space. There's a whole bunch of them. And it's exciting. It's really interesting to see what's possible. But I'm just glad we're continuing to be the ones to generate the data. And by generate, I mean capture the real data, not generate it.
I was going to say, well, I could generate a lot of data right now if that's the game we're playing.
Yeah. Generate was the wrong word.
Now, we've talked about a lot of different things. But what is Planet? You walked us through what it is in overarching terms, of course. We didn't dive into the details of that side of it. What does it do? How do these two different constellations work together? What does this mean for shipping? What does this mean for objects on the land? Who can get access to the data? How can we use? How is this analytics pipeline that you have on your side? How does it work? What is it good for? What is it maybe not good for? And then towards the end, what does the future look like? Which is the sort of future gazing thing that I like to do at the end of every podcast episode, because it helps people. Great. Well, we're not done. We're not finished. We're moving towards this world over here, which I think is really exciting. And we hear a lot of buzzwords in the space at the moment. There's a lot of excitement about the possibilities around what we can get out of images and what this data can be used for. I'd like to ask you, like, what do you think the most exciting thing is, and what do you think the biggest challenge is? When you think about, so we'll start with the exciting thing first. What's the most exciting thing for you right now in this space that you're working in? And then I want to back up and say, well, what is the thing stopping you get there?
Oh, this is a fun one because I think it's the same answer. The one thing I would actually start with is we are still fundamentally trying to do the same thing that we were trying to do when I joined 6 years ago, and probably when the company was started 10 years ago. We want to keep up to date with how the world is changing, because if we don't see how the world is changing, we can't fix it. If deforestation is taking place and no one knows about it, then we just find out when the forest is gone. Like, there are so many things that are happening, and trying to shine a light on all of it and make it possible so that you even can shine a light on all of it is crucial. What's changing is the techniques and the ability to be able to analyze this data to get to that reality, to get to that vision. Like, that was the whole point of mission 1 of imaging the Earth's landmass every day, was to be able to highlight all of that. So I easily get swept up in all of the new technology and all of the new things of just like, oh my God, look at what we can do. And it's always good to like kind of try to remember what we're trying to do and why, and then try to figure out how these new technologies, how these new things can fit into that, because the problems are not going away. So like it's generally, I just feel like that's a good preface to start with. In terms of what I'm most excited, there is a new paper, there is a new thing coming out every week that says, now we can see this type of thing in imagery. And but with this technique, I can go from, 10 meter to 30 centimeter and I don't lose any information and everything's amazing. And I think all of those things are true in the papers and that they have written. They are absolutely credible, but they haven't gotten to global scale, perhaps, or they haven't tried with this type of data, or there's always some sort of caveat, or there seems to be some sort of caveat. And figuring out which ones out of the 10,000 papers that are coming out each week, that's probably an exaggeration, but not by much. There are so many. So knowing what's real and what isn't, knowing how much, where do we draw the line to say, this is the technique we're going with and we're going to invest in it and off we go, knowing that probably next month, something better could be here. And figuring that out is both the most exciting and the most challenging thing, I think, because we have this treasure trove of data that is sitting there begging for someone, and ideally us, but if someone to find all of the gold in it. And at some point we need to just start. And I mean, we are experimenting and learning and finding all sorts of interesting things. But knowing when to stop and productize something, it's going to be difficult.
Yeah, I got to say that was a great answer, but not an expected answer. It sort of highlights this idea of opportunity costs. You could do everything, right? But then you can't do everything because you're also talking about wanting to do things at scale. So where is it that we focus our time, energy on? So that's one side of it, at least in my mind. And I guess the other side is that experimental thing. Like maybe there's no market today, but there will be something in the future, or people want to know this, will need to know this in the future. So I could see that it would be quite a difficult decision to make. What do I do now, today, because people are asking for it? And what are we going to need in the future? Because that's also going to be a problem.
I think that's right. In terms of what problems we're trying to solve and who we're working with and who we want to solve them with, that I feel like we have a good sense of. It's just there are so many new techniques coming out that we can leverage. And so really learning which ones are good for which use cases is key.
When you're talking there, it made me think of this, the saying, what gets measured gets managed. And I think at Planet, you have an opportunity to change that. Like what gets monitored gets managed. I think we should, like the satellite industry should adopt that and really push forward with that. Because when you think about these global use cases for monitoring, it is difficult to imagine another way of doing it.
Well, I think in terms of what gets measured what gets measured gets managed.
Yeah.
So a lot of this are measurements. We're measuring the crop health, we're measuring the soil water content, we're measuring the forest carbon, we're measuring all of these things that we can evaluate or see and observe from space. Yeah. So, I mean, they are measurements that we are getting, just maybe in a different way.
But again, getting back to the change over time, it's the change. Because, sure, they're healthy today. Or last time I looked, it was fine. But it's that, is it changing over time thing?
Absolutely. Yeah. Yeah. Understanding how this has changed over the last, there are so many applications for that. Yes.
I feel like this would be a great place to round off the conversation and say, hey, thanks very much. This has been great. I really, really, really enjoyed our pre-interview. Fascinating talking with you. And this has been equally awesome. So thank you very much for your time. And before I let you go, where can people go? Like if they want to know more about this, if they want to learn about some of these other products, other offerings that Planet has, can we point them towards a link, a URL, somewhere?
Yeah, the best place they can go is planet.com. Somehow you got that URL. But there's overviews of all of the different products that we talked about, whether it's roads and buildings, ships, soil water content, forest carbon, all of the things. Or maybe you just want imagery. We've got specs on all of our satellites and what's coming. That's a great place to start.
Well, again, thank you very much for your time. I really, really appreciate it.
No problem. Thank you so much.
So I really hope you enjoyed that episode with Justin Davis, our Senior Product Manager at Planet. If you want to learn more about some of the things we've talked about today, a good place to go would be planet.com, or if you are particularly interested in how you could use Planet's data and insights in GIS, go to planet.com/GIS. There'll also be a bunch of other links in the show notes today to other relevant podcast episodes that I think you might find interesting. Or you can scroll back through the archive and look for episodes and look for these episodes. Hyperspectral versus multispectral, synthetic data, and labels matter. But again, there'll be links to all this in the show notes of this podcast episode. So thank you very much for tuning in all the way to the end. It's much appreciated. I'll be back again soon. I hope that you'll take the time to join me then. In the meantime, if you want to reach out to me for whatever reason, the best place to go is mapscaping.com. You can find links to our social accounts there. Feel free to reach out to me. I would love to hear from you. Okay, that's it for me. See you again soon. Bye.